Alright, I'm going to start with number 12 here, and that is to solve an equation with a rational exponent. So what you always want to do in this case is get the expression with the rational exponent all by itself on one side of the equation. Now it already is here, so I don't have to do anything. And then once you get it by itself, you raise both sides of the equation to the reciprocal power of what the exponent is. So that means I raise both sides of the equation to the sixth power. Now I have power of a power. 1 times 6 is 6. 6 times 1 is 6. 1 6 times 6 is 1. And 2 to the sixth is 64. So I get 64 equals m, or m equals 64. So that's number 12. I want to make sure. Yes. Okay, so now 13, I do have a step in the beginning, so I'm going to have to add 3 to both sides. That's going to give me x to the 3 halves equals 729. All right, now I have the expression with the exponent all by itself on one side of the equation, so I'm going to raise both sides to the reciprocal power of 3 halves. And that's going to give me x equals 729 to the 2/3 power. And if you do that on your calculator, um, you're going to end up with, let's see, 9, you're going to end up with 81. By the way, so on your calculator, if you are using your calculator, you should put all fractional exponents in parentheses just to be safe with the order of operations. So I'm going to bring up my calculator here and show you. Let's see, I think that's under C# Windows, order of ops calculator. Yes, there it is. And okay, so I would do, using my calculator, if it comes up, there we go. I would do 729, and I would hit the exponent, and I would do 2 divided by 3, and equals 81. Not sure why that key turned yellow. That was kind of bizarre. Let's see. One more time. Huh, weird. Oh well. Okay, so back to math. All right, so 81 is going to be your answer. So you get x equals 81. Okay, so that's 13. 14, write in exponential form. Okay, so the way you do that is, so really you have that. The exponent here, because for that's outside the parentheses, becomes the numerator, and the index of the radical becomes the denominator. So I'd have b to the 1/2. As I think I've told you over and over again, the square root is the same thing as raising something to the 1/2 power. Okay, if you're going the other direction, let's see, 6m to the 3 halves, write it in radical form. Okay, well, that means, first of all, I'm going to put that in the denominator so I don't have negative exponents. Okay, so now the trick is the 2 becomes the index of the radical and the 3 becomes the exponent. So I'm going to end up with the square root of 6m cubed, and that would be it. Note the 3 becomes an exponent and the 2 becomes the index. And that's how you go back and forth between the two. Let me see. This is supposed to be a 6. No, it doesn't look like 1. So you get 1 over 6m cubed. All right, so that's 15. Simplify. Okay, so remember you want to do a factor tree of any number. So 24 is 6 times 4. 6 is 2 times 3, and 4 is 2 times 2. So I'm looking at the third power. First of all, when I have an odd exponent or index, I can have a negative under the radical. It just turns, you just bring it outside and it becomes positive. So really I'm working with negative 4 times the cube root of 24n cubed. So because I'm looking at the third root, I'm going to group my factors together in sets of 3. So I happen to have 2 3's and a 3. So once I do that, I go through each factor that's under the radical, and when I see something to the same power as the index, I cross it out and I write one of them outside the radical. So that gives me, and then I multiply what's outside the radical together, and I get negative 8 cube root of 3. Okay, that's 16. 17, same thing. 7th root of 256. Okay, so I'm going to do a big factor tree here. It's going to be 2 and 128. And that's 2 and 64. That's 8 and 8. That's 2 and 4. 2 and 4. 2 and 2. 2 and 2. So I have 1, 2, 3, 4, 5, 6, 7. I have 8 2's. So, and I'm looking for the 7th root, so I'm going to write my 8 2's as 2 to the 7th times 2 to the 1st. That is 2 to the 8th, and I have 8 2's multiplied together to give me 256. Now I go through, and the 7th root of 2 to the 7th is just 2. So now I multiply what's outside the radical together, and I get that. Negative 8, 7th root of 2. Okay, write in exponential form. So once again, the power, which in this case is 1 since there's nothing written there, becomes the denumerator of the exponent, and the index becomes the denominator. So I would have 10x to the 1/4 power. You could also write that as 10 to the 1/4 x to the 1/4. Either of those is fine. Okay, now we're going the other way. So write in radical form. So I know the 6v is going to be under the radical. The 2 becomes the index, and the 5 becomes the power. So I would write square root of 6v to the 5th power. And since it's the square root, I don't even need to write the 2 as in the index. It's assumed if you have nothing that where you're talking about the square root. Okay, so how many more of these do we have? Okay, down to solving equations. I'll just do a few more in this screencast. All right, do a factor tree for 162. And I have 3 to the 4th times 2. So since I'm talking the 4th root, I'm going to write 162 as 3 to the 4th times 2. And I'm going to write p to the 5th as p to the 4th times p to the 1st. Then I can go through anytime I see the fourth root of something the fourth power, cross it out, write one outside the radical, multiply everything outside the radical together, and you get negative 3p. And what's left under the radical? A 2 and a p. All right, cube root of 108. 108 is 2 and 54, 9 and 6, 3 and 3, and 2 and 3. So I have 3 3s and 2 2s. So I'm looking at the third root, so I'm going to write that 108 as 3 to the third power, times 2 squared. Okay, I can cross that out, and I get 6 times the third root of 4. Okay, I think I'll stop for there. So that's working with higher order radicals and simplifying expressions with higher order radicals. So I'll stop and we'll pick it up in the next screencast.